Welcome to this video on Kubernetes Health Checks. Today, we'll explore how Kubernetes monitors the health of your containers using Liveness and Readiness probes. Understanding these probes is essential for building reliable and self-healing applications in Kubernetes. By the end of this video, you'll know exactly when to use each type of probe and how they work together to keep your applications running smoothly. Before we dive into the specifics, let's understand why health checks are so important. Kubernetes needs a way to know if your containers are actually working properly, not just running. Health checks enable automatic detection and recovery from failures without any manual intervention. This means your applications stay available and reliable, even when individual containers encounter problems. Think of health checks as the automated doctor that continuously monitors your application's well-being. Let's start with Liveness probes. A Liveness probe checks if a container is still running and responsive. Its main purpose is to detect when an application gets stuck in a deadlock or enters an unrecoverable state. When a Liveness probe fails, Kubernetes takes decisive action by restarting the container. This is crucial for applications that might hang or freeze but still appear to be running from the outside. The Liveness probe essentially answers the question, is this container alive and functioning? Here's a practical example of how to configure a Liveness probe. This probe uses an HTTP GET request to check the health endpoint at /healths on port 8080. The initialDelaySeconds parameter tells Kubernetes to wait 15 seconds after the container starts before performing the first check. This gives your application time to initialize. The periodSeconds parameter means Kubernetes will check the health every 10 seconds after that initial delay. If the endpoint fails to respond or returns an error, Kubernetes will restart the container. Now let's talk about readiness probes, which serve a different but equally important purpose. A readiness probe checks if a container is ready to serve traffic. This is especially useful during startup when your application needs time to initialize, load configurations, or establish database connections. When a readiness probe fails, Kubernetes doesn't restart the container. Instead, it simply stops sending traffic to that pod by removing it from service endpoints. Once the probe succeeds again, traffic resumes. The readiness probe answers, can this container handle requests right now? Here's how you configure a readiness probe. This example also uses an HTTP GET request, but notice it checks the /ready endpoint on port 8080. The initial delay is set to just 5 seconds because readiness checks typically need to run earlier than Liveness checks. The period is also 5 seconds, meaning Kubernetes checks readiness more frequently. This configuration ensures that your pod only receives traffic once it's truly ready to handle requests, preventing errors during startup or temporary overload situations. Let's compare these two probe types side by side. Liveness probes detect broken or stuck applications and trigger a container restart. They answer the question, is it alive? Readiness probes, on the other hand, detect temporary unavailability and simply remove the pod from service endpoints without restarting it. They answer, can it serve requests? Understanding this distinction is critical. Use Liveness probes for permanent failures that require a restart, and readiness probes for temporary conditions where the container just needs time to recover or finish processing something. Let's wrap up with some best practices. First, always set appropriate timeout values based on your application's characteristics. A slow application needs longer timeouts. Second, use both Liveness and readiness probes together for comprehensive health monitoring. They complement each other perfectly. Third, keep your probe checks lightweight and fast. Don't perform expensive operations in health check endpoints because these checks run frequently and shouldn't consume significant resources. Following these practices will help you build robust, self-healing Kubernetes applications that can handle failures gracefully and maintain high availability.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.